Section 9.2 talks about graphing and writing equations of parabolas. All of Chapter 9 is covering conics, and conics are kind of the geometric construction behind, you're going to be making parabolas, which you're familiar with, ellipses, hyperbolas. So a lot of graphs that you've made, but we're going to focus on the geometry behind it. And you're going to be doing parabolas in section 9.2, and you are familiar with vertical parabolas, you know, that look like this, or of course they can open down. We're also now going to look at horizontal parabolas that either open to the right or to the left. You're also going to be taking an in-class test with a partner on chapter 9. So knowing that, you can use any notes that you take. So when you're watching these videos, I would highly recommend taking notes. And if you take, or if you write down at the very least anything, I would write down formulas for sure, because those are the things. I'm not going to give you any formulas on the test, so if you don't have them in your notes and you don't remember them, then you're going to be in a world of hurt. So here we go with parabolas. All right, so you know what a parabola is, and here I have a picture of a vertical parabola, and you know how to test points and pattern of change, but all of that stuff you really aren't going to use much in the conic section. So 2 words, jot these down. These are your important characteristics, and by the way, on your test, for every conic that you look at, you're going to be asked to list all of the important characteristics. So important characteristics are pieces of the parabola, and you're going to have 2 of them. You're going to have a focus, which is a point, and you're going to have a directrix that is a line. And I'm highlighting that because oftentimes people write the directrix as just like a number, and it's a line, so you should have an equation. So the focus is a fixed point that lies on the axis of symmetry of a parabola, and I'm just going to draw in here the axis of symmetry. Remind yourself that that cuts the parabola in half symmetrically. So the focus point, which is right here, will always be inside the parabola, and that is a fixed point inside the parabola and will lie on the axis of symmetry. Then the directrix is a line that's perpendicular to the axis of symmetry, and that is always outside. In this case, it's below the parabola. So here's my directrix line, and that is equal distance, excuse me, by the way, and perpendicular to your axis of symmetry. So if I know that from my focus point to my vertex is 3 units, then from my vertex to my directrix line is also 3 units. Now the other cool thing about this is any point on the parabola, not just my vertex, is equal distance to the focus point and to the directrix line, the shortest distance. So if I take this point for example, since that's one they have highlighted, if I find the shortest distance to the focus point and the shortest distance perpendicular to the directrix line, those should be the same length, so B units and B units. Another example here, they have this point on the parabola, A units to the focus, A units to the directrix line, equidistance. And I mean, really, you could take any point. You know, I'll take this point right here, equidistance to the focus as it is to the directrix line. So if that's 2 units, that's 2 units. So that is the definition of a parabola. Any point on a parabola is the same distance from the directrix line as it is from the focus point. So again, here's your focus point, and here's your directrix line. Take any point on the parabola, and they just have this point highlighted, and this distance to the focus point and to the directrix line should be the same amount of units. All right, here are the equations that you should for sure write down. They're going to look different than what you're used to. So these are standard form equations, by the way. So if you have a parabola that's vertical, it is going to have a vertex at the origin, and if it's horizontal, it's going to have its vertex at the origin, and of course they can open to the left and down also, but I won't draw those in there. So if you have a vertical parabola, you're probably familiar with like y equals x squared. So you can imagine that if it's horizontal, it's going to be x equals y squared. But in addition to that, I'll go back to my vertical parabola here. There's this p-value, and p, I'm actually going to define up here, is the distance from your vertex to your focus point. Okay, so if they're centered at the origin, then that means P is just going to be your focus point. So let's say that P, or my focus point, is 3 units. Well, then the point 0.03 right there is my focus point. So x squared equals 4py. So notice this is the same except for there's a 4p tossed in there. And again, that's kind of the geometry behind the construction. So if I have enough information here to solve for p, and you always will have enough information, that P is going to tell you where your focus point is. So if it's vertical, your focus point is obviously always in the y direction, so in this case 0P, and your directrix line is always equidistant but in the opposite direction, so it's going to be negative P units, and if I just kind of draw that in, that line would be right there, and that would be y equals negative whatever P is. And that's this equation. So equation, point, focus point, directrix line. And then your axis of symmetry, of course, is vertical because it's a vertical parabola. Now, the horizontal one, which you're not as familiar with, everything is just reversed. So you're going to have y squared equals 4px, and that means your focus point is on the inside of your parabola, but on the x-axis. So notice it's p comma 0, and your directrix line equidistant on the outside of your parabola. And notice that's x equals negative p. And of course your axis of symmetry is horizontal because it's a horizontal parabola, so y equals 0. So we're eventually going to shift these not at the origin, so it's really good to have these formulas down so that when we do shift, especially understanding what p tells you, not just how to find p, so the distance from your vertex to your focus.